Welcome back. Problem 12-8. So statement is the shaft is supported at A by a journal bearing that exert only vertical reaction on the shaft, and at C by a thrust bearing that exert horizontal and vertical reaction on the shaft. So determine the equation of elastic curve using coordinate x1 and x2. EI is constant. So this is the shaft that is supported at A and C by bearings. There is a point load at point B. The length from A to C is A, while from C to B it is B. So this is coordinate x1 from A, and this is coordinate x2 from B. So you have to find the equation of elastic curve using coordinate x1, which will give you V1, and equation of elastic curve or deflection in term of x2. So let's start with the solution. So first step is that if we remove this bearing, so we will have a reaction force which is Ra, and if we remove this bearing, so there will be a reaction force which is Rc, as well as there will be a horizontal force, because that is given in the question. But the horizontal thrust will be equal to 0 because Rcx. Okay, so that will be 0. So we will find this unknown reaction force by equation of equilibrium. The first equation of equilibrium is that sum of all moment about point C is equal to 0, and taking the counterclockwise moment as positive. So about point C, one moment is due to Ra into perpendicular distance is A, and this will produce. Okay, before going it, this force is downward, this is upward, so this should be also downward in order to bring it equilibrium. So make a correction over here. So first movement is Ra into perpendicular distance is A about point C, and it is producing clockwise movement, counterclockwise movement, so it will be positive. And due to this P, we have perpendicular distance is B, and that is producing clockwise, so it will be negative. So I will write Ra into perpendicular distance is A minus P into B is equal to 0. So from here you will get Ra is equal to P into B divided by A. Okay, now we have this Ra, we can find Rb, that is sum of all forces along y direction must be equal to 0, and upward force is positive. So we have Ra, which is downward, and that is Pb over A plus Rc, which is vertical force, minus P is equal to 0. So from here you will get Rc will be equal to P into 1 plus B by A. We will be using only Ra. You can see that we will use Ra. Now, if you cut this beam at a distance of x1 and draw the free body diagram of this, so it will be like this. So this is a point where we have Ra, and that is Pb over A, and we have this distance is x1. So if you cut it, there will be a shear force which is V1x, and there will be a moment which is M1x. Let this is your point 1. So you can find this moment, sum of all moment about point 1 is equal to 0, and taking the counterclockwise moment as positive. So about point 1 we have M1 of x, which is counterclockwise, so it will be positive, and this one PBA into perpendicular distance x1, this is also counterclockwise, so it will be positive. So their sum must be equal to 0. So PB over A into x1 plus M1 of x is equal to 0. So from here you will get M1 of x is equal to minus PB over A into x1. So this is your moment equation. Now we'll find the moment equation for here when you cut it from here, and you will draw the free body diagram. So it will be like this one. This is your point P, clear, and this is the distance which is x2. So if you cut it, you will have a shear force which is V2 of x, and there will be a moment which is M2 of x. and this is 0.2. Now by applying equilibrium condition that sum of all moment about 0.2 is equal to 0 and taking the counterclockwise moment as positive. So one moment is this m2x, which is clockwise, that is negative, and other one is p into perpendicular distance is x2, and that is also negative because it is clockwise. So I will write minus m2 of x minus p into x2 is equal to 0. So from here m2 of x will be equal to minus px2, p into x2. Now this is the moment equation when you use coordinate x2. So I will draw a line so to differentiate both these two. So we know that from equation of slope and elastic curve we have ei into d square v over dx square is equal to m of x. So for coordinate x1, for x1 this equation will become ei into d square v1 over dx1 square is equal to m1x, and 1x is minus pb over a into x1. So if you integrate it once, so you will get ei into dv1 over dx1 will be equal to minus pb x1 square over 2a plus c1 x1. Okay, so if you divide ei on both sides, so you will get dv1 over dx1 is equal to 1 over e into I multiply by minus pb x1 square over 2a plus c1 x1. Let this is your equation number 1. Again integrate it, you will get v1 will be equal to 1 over e into I, and we will get minus pb x1 cube over 6a plus c1 x1 square plus c2. Let this is your equation number 2. Now we'll move here for coordinate x2. We will having this equation ei into dv2 square over dx2 square is equal to m2x, which is minus p into x2. So integrate it, you will get ei, if you integrate it, you will get ei into dv2 over dx square, dx2 will be equal to minus px2 square over 2 plus c3. Clear? And if you divide ei on both sides, so you will get dv2 over dx2 will be equal to 1 over ei multiply by minus px2 square over 2 plus c3. Let this is your equation number 3. So again integrating it, you will get v2 is equal to 1 over ei into minus px2 cube over 6 plus c3 x2 plus c4 is equal to equation, let this is equation number 4. Now we'll use boundary condition in order to get c1, c2, c3 and c4. So what are the boundary conditions? So I will write first boundary condition. So we will use first boundary condition is that at x1 is equal to 0, we have v1 is equal to 0 and put it in equation 2. Okay, so let me show you that at x is equal to 0, we have here V1 our deflection is equal to 0. And similarly we will use another condition that at x1 is equal to a, we have V1 is equal to a, because due to this we have a deflection like this. Clear? So first we will use this condition. So when you put x1 is equal to 0, v1 is equal to 0 in equation number 2. So this term will be 0, this term will be 0. So and v1 is equal to 0. It means that c2 is equal to 0. So when you put it, you will get c2 is equal to 0. Now another boundary condition that I have written, at x is equal to a, we have v1 is equal to 0. So put it in equation 2. So when you put it in equation 2, so you can see that this term will be 0, this term will be minus pb a cube over 6a. So it's better to write 0 is equal to 1 over ei into minus pb, x instead of x1 we have a, so a cube over 6a plus c1 into a plus c2 is again 0. So from here you will get c1 will be equal to pab over 6. So you have c1 is this. Now we will move toward here. We will also use boundary condition that x2 is equal to b. We have v2 is equal to 0. So let me show you that here you have x2 is equal to b. So here v2, our deflection will be equal to 0. So we will put it in equation 4. So when you put it in equation 4, so you can see this is the equation number 4. So 0 is equal to 1 over ei, and this is minus pb cube over 6 plus c3 x2. Instead of x2 we will use b, c3 into b plus c4. So from here you will get c3 into b plus c4 is equal to pb cube over 6. So this is your equation number 5. Now we will use continuity equation. So what is continuity equation? So continuity equation is that at x1 is equal to a or x2 is equal to b, we have dv1 over dx1 will be equal to minus dv2 over dx2. So I will show you here. This is point where have x1 is equal to a and x2 is equal to b. Here the slope will be same, but one is in clockwise and other one is in counterclockwise direction. So this is the continuity equation. Now you can see that we have dv1 over dx1 is equation 1. This is equation 1 and this is equation number 2. So they are equal, but we will multiply minus with all this term. So I will write it dv1 over dx1 is equal to minus dv2 over dx2. So dv1 is this term. So I will write first 1 over ei into minus pb x1 square over 2a plus c1. c1 is pab over 6 into x1. Okay. Now this is dv1 over d2 minus we will multiply 1 over ei dv2 over dx is this one. So minus p into x2 square over 2 plus c3. c3 is not known. c3 is not known. Okay. c3 is not known. Now put x1 is equal to a and x2 is equal to b in this equation. So when you put it, you will get 1 over ei will cancel with each other. So you will left with minus pb a square over 2a plus pab in over 6 minus pab over 6. This is c1. So we do not have x1 with c1. You can check over here. Let me show you. This is c1 x1. c1 x1. So c1 is pab over 6 and x1 is a. Okay. Where is, let me check it. dv1 over dx1 is c1. So make a correction. This is not x1. This is not x1, because if you integrate you will have only c1. So make a correction. Okay. So again this one will be also equal to c1 x1. Okay, now it's correct. Okay, so what we will do is that this will be now equal to PAB over 6 is equal to PAB over 6 is equal to minus will, this minus and this minus will be plus. So plus p x2 is b, so b square over 2 minus c3. So you will get c3 is equal to, if you further simplify it, you will get c3 is equal to this plus pba over 2 minus pab over 6. Upon further simplification, you will get c3 is equal to pb square over 2 plus pab over 3. So you can take the LCM of these two. So this will give you this value and this will remain same. So this is the C3 value. Now put the value of C3 in equation number 5. So equation number 5 is this one. So when you put the equation, so equation 5 is C3 into B plus C4 is equal to PB cube over 6. So from here you will get C4 is equal to PB cube over 6 minus C3 into B. So C4 is equal to PB cube over 6 minus C3 is PB square over 2 plus PAB over 3. So C4 will be equal to PB cube over 6 minus PB square over 2 minus PAB over 3. Okay. So okay, so we haven't multiplied b with this, so this will be cube and this will be square. Okay, so further simplify it, you will get C4 is equal to minus PB cube over 3 minus PAB square over 3. Now you have all the value of C1, C2, C3 and C4. So put C1 and C2 in equation number 2. So this is equation number 2. You can see this is your equation number 2. So you will get V1 in term of x1. So I will put it, V1 is equal to this equation number 2 was 1 over EI into minus PB x1 cube over 6 a plus PAB over 6 x1 plus C1, sorry, plus C2, but C2 is equal to 0, so this is C1. Okay, so after putting the value of C1 and C2 in equation number 2, you will get this equation. And if you further simplify it, so if you take P over 6 AEI and you take B as common, so you will left with x1 cube over here minus a square into x1. So this is the value of, or this is the deflection equation of elastic curve, or deflection equation of deflection in term of x1. Now what we will do is that put C3 and C4 in equation number 4. So this is equation number 4. You can see this is equation number 4. Put the value of C3 and C4. C3 is this one and C4 is this one in above equation. So when you put it, you will get V2 is equal to 1 over EI into minus P into x2 cube over 6 plus C3x. C3 is PB square over 2 plus PAB over 3 into x2 plus C4, and C4 is minus PB cube over 3 minus PAB square over 3. So again, if you take some terms common, just like P over 6 common, so you will left with minus x2 cube plus b into 2a plus 3b into x2 minus 2b square into minus a minus b. So this is equation of elastic curve in term of x2. And this was all about problem 12.8. You can see it's a very lengthy problem, but if you try it by yourself, I hope you will be able to solve such type of problem. Again, if you have any question, you can ask me in comment section. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.